Welcome back. Welcome to the final talk in our user interface track this afternoon. Before we get into the talk, I just want to remind you that after this talk, so there's one more talk, and then there's going to be a short break, and then for the rest of the day, for the final hour, there are lightning talks. The lightning talks are not all in one place. They are split between, I think, 3 or 4 different rooms. So after this talk, you have 15 minutes to work out in which room you want to go to, which lightning talks you want to go and see, and then get there, because the time's quite short on those, and so we need to be prompt with them. So please, after this talk, work out which talks you want to go and see, which lightning talks, and then make your way over there quickly. With no further ado, I would like to welcome Attila, who's going to finish off this session by teaching us something about UI prototyping.
That's correct. Thank you. All right. Hello, everyone. I'm Attila Csipa, and I will be talking about fast QML prototyping for platforms without QtQuick support. And I guess this will be probably the only session where we will be focusing on use cases and platforms that do not have Qt, which is, I guess, a bit odd for Qt Dev Days. But we have a reason, and I'll show you how you can get around this and how you can turn this disadvantage into your advantage. So, without further ado, first I'm gonna just outline of what exactly are we talking about here. So prototyping, then go over the reasons why we are doing this. So what are the motivations? What are the factors, both in terms of business, technology, the whole process and such. What are the cases when we don't want to do it? So what are the reasons that are advising us against this? And I will just as an example, present 3 different techniques that I use personally to get around this and use QtQuick and QML on platforms that do not have QtQuick support. Finally, there will be two case studies that leverage these techniques that I will be describing. One will be the Nokia Asha. The Nokia Asha doesn't support Qt, so you will see that you can do all sorts of trickery with it, and you can just get so much more in terms of productivity when prototyping the UIs for it when using QtCreator and QML than the default tools that I was surprised myself. And finally, the other case study, which will be focusing on a console UI. There are still reasons, especially in the embedded space, where you want to do, or servers where you want to do console UIs. So without further ado, let's see all this. So we want to do fast UI development. That's sort of everybody wants to do that. Who doesn't? However, there are some things that are easier to do. There are some things that are more difficult to do. So Qt as such has been evolving, and they discovered that yes, declarative UIs are good. You should have a terse syntax. You should have a declarative UI. You should have quick iteration cycles, and you will say, hey, this looks very familiar. And fair enough, this is actually what QtQuick and QML gives you: a declarative UI language for the very terse syntax, readable, and something that allows you to iterate quickly, which is very important when you're prototyping a UI. However, there is a snag. It's not that easy. Not all platforms have this. So unfortunately, 2013, and still the number of platforms that have QtQuick is unfortunately in a working good condition is limited. So what are the cases? So first of all, there is the case when we have a policy that says, no, you cannot run Qt on this. We don't allow you. So we have heard that there are cases, for example, like with QtWebKit, that there is a store policy that says you cannot publish here. So the same thing here. There can be various reasons, whether it's the JavaScript, whether it's because it's interpreted, whether it's something else. But simply it can be a policy decision. Somebody says you cannot deploy Qt binaries on this platform. So that's one case, policy. It's very hard to fight, but we'll see we can even go around that. The other problem, especially now with QtQuick 2 and Qt 5, we have this requirement of OpenGLES. And the scene graph story is very good. It makes us, enables us to do very quick and very nice animations and all the user interface, modern user interfaces. However, not all platforms actually have OpenGLES, and probably some will not have ever. So that's a bit of a problem. So what else? Resource limits, of course. There is always, cases where you don't have enough memory. because JavaScript engines also take up space. There is not enough bandwidth. If you are pushing this UI through a network, then the VNC or something else is out of the question. There is simply not enough disk space to put the things in there, and you can go along and simply there is a resource limit, and you can sometimes get surprised what life hands you. Like you have to make this work, and you get a pile of very, very resource limited hardware, and you have to make do. As an example, that's my cheese sandwich from a flight in Brazil. So I was asking, should I buy some food? And they said, well, there's food on the flight. I say, okay, it was early morning, yeah, not hungry. So then I got my cheese sandwich. So that was the meal of the day. So you have to make do. All right, but there are other simpler reasons also. Simply, there is no native look and feel. So you can draw your own pixels, but that's not really sort of a fast way of prototyping UIs, is it? So there is maybe no native QtQuick based component set, or simply there is no integration with the target platform. So your little application is an island. So in terms of UI, that can be a very, very annoying thing when, for example, you have a platform which has swipe and your application just doesn't react to it. So that can be very, very annoying. So we had a number of cases where we just cannot apply QtQuick. So this sort of tells us the story in terms of what we cannot do, but let's explain why do we want to go to this nasty ground of sort of forcing it. So there is, of course, a business angle, there is a technology angle, and finally there is a development angle. Let's see first the business angle. There is, a lot of non-QtQuick capable devices. So, for example, the Series 40 family, which runs Java ME, has something like 650 million plus active devices out there, and we sort of like ignore them. Like, well, whatever, 600 million devices, not important. It doesn't have OpenGLES. We don't care. So there might be a serious business consideration there. Some of these might be sort of usable, but they have very, very bad UI prototyping tools. So when I write for example, UIs for this guy, I want to pull my hair out, not because of the hardware limits, but because the tools are so, 10, 15 years ago that it's just hard to do. So I have to code for, 30 minutes so I can try and see, okay, this is not what I wanted, and then go back again. So that's something super annoying, and we can help this with QML. Another business proposition, a foot in the door. So we can say, well, we will not handle this problem. We cannot deal with it because there is no good Qt support today for it, so we don't care. At the same time, we could say, we can bridge this gap and provide a solution, a prototype, something simple, just to show that we are very capable. And then on the next iteration of the project, when Qt support is at the level where we can do it, then we already have a foot in the door and we can continue working on projects with these people. So that's something also very, very important from a business angle. Accessibility. So we heard that Qt 5 is now also getting a lot of accessibility options here, but we can also provide some custom platform provided ones. In some cases, this is very weird. So for example, for special devices, especially embedded, for blind people or people with hearing or any other impairment. So it's all there. And finally, of course, fame and glory. That's how I got here. So that's the one business angle. The technology angle. So why do we want to use this? Minimize resource usage. So QtQuick is, we are hearing the story that yes, it's very lean and it's very, not intensive and all that, but we are kind of looking at it from the high-end supercharged mobile angle, maybe, where we are used to, like, even your phone has like a number of gigahertz and cores and whatnot, so everything has it. But the fact of life is that most of the phones still are not, quad core, whatever. So they are very, very modest hardware where you have to count every byte and every hertz. The other thing is there are maybe niche applications, but things like with applications with multiple UIs. So you have an application and you want to be able to start it from wherever. You don't really care whether that display is a touch screen, is it a serial link that is just connected to a keyboard, a little text display, or is something else. So you can simply decouple your application from the screen and user input, and that makes it very, very nice to have as a very versatile option. And the most important, the sort of all the story or everything I was talking so far was the build-up for this, is the development angle. We are talking about prototyping. How do we get quick UIs? how do we iterate quickly? So it's not just about getting a design and trying to implement something, but rather, iterating over it, see what works, see what doesn't work, and then improve it. So working hand in hand. So here's the thing: we can reuse our knowledge of QML. So different platforms work differently. Our knowledge of QML can help because we are going to use it. We can complement the lacking IDEs with QtCreator. So for example, I will be returning to this because I work with these devices a lot. The recommended default environment is Eclipse. It's a kind of a bloated thing, in my personal opinion, but that's the default thing, and it doesn't really have a UI designer. I write code line by line, every widget, every attribute. It's really, really tiring. You can see I will have some code examples. It's very bad. Still, we also get the complementary package, which is like syntax highlighting, auto-completion, and of course, in some cases, debugging, which is good stuff. There is a single language interface between developers and designers. This is super, 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 super important. So when I'm showing designers QML every day, then they sort of get used to it. They're having an idea of how this looks like, how does this work. If I show them different platforms, like today I'm showing you Java stuff, tomorrow I'm showing you Qt stuff, the day after that I'm showing you Windows stuff, so Metro, whatever, and they get confused, like, okay, we get the design, but the back is completely, we are clueless of what's happening in the back there. So this is a simple interface that you just have to sort of roughly understand QML, and you can even try yourself, changing some basic parameters, and there is not, a new technology or a new approach that you need to learn every day for every platform, because we do have a number of them. And this also means that less people need to know platform specifics. So you don't need to care about the implementation details. You just need to go as far as QML. You don't have to do the grunt work. We have, platform specialists for that. And all this means faster iterations, hopefully less painful, even though it sometimes looks a bit silly, but don't worry, it's all for the better good in the long run. However, this was a very nice story, like, okay, yeah, we want to do this QML all the way. So, okay, so why not do it? There might be some consequences. First of all, maintenance burden. When you are doing your own component set, when you are, trying to do something that the platform doesn't want to or has been, abandoned years ago, then you have to carry it, and it's really, really a burden. So it's a hard thing. And then, of course, it's hard to upstream because nobody wants kludges, nobody wants patches. So that's all yours. And of course, there is limited flexibility. So you cannot use everything you had in QML. You have to sort of keep in mind what the platform has for you. And there is a reason QtQuick exists. It's cool. Use it whenever you can. This is for cases where you cannot use it. So this is just for the prototyping part. And as somebody said, Dan Dodge, the QNX CEO in today's keynote, the world doesn't need another piece of crap. So when you are prototyping, keep in mind it's a prototype. So when you are, you have a solution, then please implement it correctly. This is really just a faster way of getting to the target. All right. Any questions so far? All right. So let's see what we can do here. So we heard we can probably use QML somehow in these cases. We just don't know yet how. I will present 3 cases. I will roughly talk about the workflow. What are the prerequisites for each one? What are the advantages? What are the disadvantages? And what problem domains I would use these for? Let's see. I will have a roll your own component set. So when I'm not using QtQuick, I'm using QtQml, so defining my own component set, and then therefore addressing hardware that is maybe not supported by QtQuick 2, for example. The other approach will be code generation, where I generate code from my QML, and that code gets compiled for the target platform and runs on it. And finally, something very nasty, client-side QML, where I push QML over to the device, and the device actually constructs the UI based on that QML. It's as scary as it sounds, don't worry. So let's see these approaches in detail. First of all, the roll your own. I'm not sure how many of you are familiar with this, but so QtQuick and QML are actually 2 different modules. So they are decoupled. So the engine that parses the QML, that hooks it into the JavaScript engine and all that, is something completely separate from the rendering engine. So the one that gives you the rectangles, all the graphics items, the images, and puts them in the scene graph, all that stuff. So these are 2 completely separate things. This means that I can just forget about that drawing imaging part, which is actually tied to the hardware, and just deal with the QML part as such. And this is why this is practically the exact same workflow as a normal QtQml workflow as it would be. So what do we need for this? We need, of course, Qt on the target platform and the functional QtQml module and all its dependencies. So these are the cases where we probably, for example, are working on a Linux computer. It doesn't have, let's say, OpenGLES, that sort of thing, but we do have Qt on it, so that's pretty okay. The advantages are that we are still have the full grunt and power of the JavaScript story, the QML story, and we have, of course, access to signal slots, the event handling, and we even have the QML debugging active from QtCreator. So it actually gives us almost all of the benefits. And of course, the disadvantage at the same time is that we actually do require QtQml on the target platform. So that wouldn't apply for this guy here. All right, what are the problem domains for this? Since it actually takes quite an effort to write this component set of your own, as you can see, we waited so long for, let's say, desktop components. So it took a while to get there, and it's going to take a while, for example, to get the Windows ones with the new Metro style and everything. So it's really just for simple problem domains. Otherwise, I would say that it would just take too much time doing it. So, for example, if you are doing a text mode UI, that's a perfect match for this. Or if you have some custom hardware that you want to output things. For example, if I was doing the blinking lights things, so this is this case where they put a building and the lights were switched on and off by a program. So it's actually acts as a display, the whole building. For example, that sort of output can be handled by this approach. All right, any questions regarding this? And of course, I will show all these in sort of the real life in terms of the use cases that I am having on both the Asha devices and, as you will see, a text mode UI. Any questions? Okay, so client-side QML. I mentioned this. So what does this actually mean? So what I'm doing here is that I create the QML in QtCreator, write it normally, and then I do just a little bit of mongering with it. I remove the import statement because that's really not JSON syntax. And there are a few escape clauses that you might need to apply. But the general idea is that QML is actually very, very close to JSON. So I can use JSON parsers to pull it apart and then reconstruct it on the target device. And that's what I'm doing here. I'm pushing over that cleaned up QML to the device, loading it on the device on a local application, and then constructing the UI from that. And then rinse and repeat. Why is this good? Well, the good thing here is that, first of all, I don't need Qt on the target platform at all. Since I'm pushing over the QML, the source file, then this is very, very easy. That actually has the only requirement of having just simple JSON parsing, and that's it. Everything else is completely optional. The disadvantage is that this is actually a lot of work. So I'm sort of recreating what Qt does on the other platforms, and that's something that is really a lot of work. So you don't get the JavaScript advantage. It's really difficult to debug because you don't know exactly what's going wrong when it blows up, and you really have to have a good understanding of the target platform. However, this doesn't require Qt is a very, very big advantage. I'll show you how this client-side QML is also being constructed. So the problem domain is really platforms with no Qt support, and I'm primarily using it to basically test static UI designs and mockups. So I just get, QML is just so terse, so nice that I can write something or change something very quickly and then load it up on the device and don't worry about the native side implementation at all. Here's an example. How many of you are designers here primarily? Hands up. Don't worry, it's not a shame. That's okay. All right. So because I'm showing code, so I can warn you to close eyes. So for example, I am showing you what I'm doing in Java ME with a library called Tantalum, and how I get to construct a UI from QML, even though I'm not having Qt there at all. So it's actually a very simple thing. I have JSON objects which are provided by the Tantalum library. I load up the data that I'm received either through the network or the file system. I check for errors. If it's parsable, not an object, or not a JSON compatible, etc., then I will just return. If not, I will do the following. So here I'm constructing or checking for an application window object. This is, in my case, hard-coded. Yeah.
So is it really only stripping off the import statement?
Yeah, there are a few special cases. So if you actually had JavaScript in there or that sort of thing, that of course breaks the stuff. But you should be aware that hey, filter out or don't put that thing in. Or depending on how your platform handles strings, there can be some escape issues. But normally it's actually very close. So in most of the cases, you can just simply strip the import statements, maybe check for the version if you wish in the beginning, and that's it. Yeah. All right. So I get the application window object from the JSON file. In my case, I will just, so this is just a subset. And I will check for example, options. Do I have in my application window any options? And if I do, I will iterate over them, get the text for them, and finally add them to my displayable. That's the name for the thing that is essentially visible on the display for the phone. And of course, add the commands to the displayable itself. So, and some error checking at the end. So this is the simple thing here. So what I did was I actually parsed the QML and constructed the UI on the device. The device has no idea that this is QML as such. It's a JSON file, which is essentially a spec for it, how to construct UIs. And the good part is that this means that it doesn't matter what the device has, as said. So this doesn't touch on Qt as such at all. However, in most cases, the QML syntax will be a lot terser than if I did this manually. So I coded the whole thing that you will see, for example, on Java ME, it's really, really verbose. So, just loading an image is usually, 5 or 6 lines where you handle all the exceptions and everything. And that's just so much more elegant when you do it in QML. I will leave you the comparisons for later. And finally, a bit more maybe challenging, but also a lot smarter approach is code generation. It's very similar to the previous one. So I write my code in QML, but the output is actually source. So it's source code. So for example, if I was writing for this guy, when I run my QML viewer, I end up with a Java file that I can then compile and push the device. The application window object is the one that contains this sort of code compilation part, and it's really just about serialization. So you can see that it's also you will see that it's also a very, very simple way of getting out of the Qt dependency, but still retain the QML goodness. So what do we need for this? For this, we need the tools of both Qt and the target platform running on the same device. So for example, if you have Windows, that means that I will of course need, let's say, QtCreator, and in the case of a Series 40 device, I will need the Nokia ID, not ID, is the SDK, sorry, the SDK running on the same device. And the advantage of this is that since I'm serializing, basically my QML objects myself, I can do that any way I want. There is no correspondence or requirements as to what I'm outputting here. It can be any language. It doesn't even need to have JSON parsing the target platform at all and all that. The disadvantage, on the other hand, is that the JavaScript and the bindings themselves are sort of a question mark. So some platforms do have JavaScript support, and that's good, but some don't. So if they don't, then you cannot include that, or you have to do some tricks yourself. And of course, it's a lot more complex because you are doing code generation. So that's always a complicated topic. The applicable problem domain for code generation is, again, platforms with no Qt support at all, but the advantage compared to the simple QML construction is that light logic can be included. So since we are generating it, we are a lot more flexible as to what we can put in there. So code generation is in effect a source code level deserialization or serialization. So we are getting our QML. We have a completed object ready in QML, so that the Qt engine has a completed object, and then all we do is we output, serialize it into the whatever language we are using on the target platform. Very simple. And now the examples, why this is working, and sort of like what unexpected places I took this approach or these approaches to. First, the Nokia Asha software platform. So bear with me, Just to understand why I had to do this the way I did, I will say a few words and waste a few minutes of your life introducing you this platform. So it's completely unrelated to Qt, don't worry, but there will be images for the sort of entertainment effect, so I hope that you can make it through. All right, so this is a Series 40 device. The Series 40 started in 1999 with the Nokia 7110. So it's been a while. All that. It's not Symbian, so let's get that out of the picture. It's not nothing has to it has to do nothing with the sorts. And if you think that 1999 is sort of like a really long time, just remember that Qt is actually 4 years older. So just to put things into perspective. All right. So a few years later, actually Nokia sold 1.5 billion of these by January 2012, and there are still, well over 650 million active those, and then plenty of those are touchscreen devices. So that's a very good target market, and nobody's writing apps for these. That's why I started doing this. So the Eskimo to seal ratio in the ecosystem is very, very, very good, because you have a ton of devices and nobody's writing code because it's lame. So earning money is lame nowadays. So that's why it's sort of, it was like, so can we help this? So we know that freemium and ads do work on this platform. It has, its way, and time has passed, and that's the thing. The world has changed. So we develop software differently. We do stuff very differently, and the Asha platform itself changed a bit. So what happened in this world? What they did was that Series 40 hardware adaptation got a SmarterPhone middleware slapped on top. By the way, SmarterPhone was developed by the same people who actually founded Trolltech and Qt back in the days. And there is a swipe UI on top of that, which is the familiar UI from the Nokia N9, for example. So it looks very much like it. And here is the problem. The developer offering. It's kind of maybe a letdown. If you are working with Qt platforms on let's put it this way, newer or more higher-end devices, then this can be like very daunting. So there is of course Java ME, which is not that big of a problem. It's a subset of Java as such. There is a number of JSRs, which are APIs for this and that. But the problem, jar file size 5 megabytes. So my app must fit 5 megs. The Java heap, my application memory usage is basically 3 megs. What? So there is a number of problems. And I see your faces, and I think I have pretty much everybody from this picture. So so it's really like, oh, wow, how exactly are we going to do software development on this? Somebody is just like, what? So what is Qt doing in this story? Is this whole just a giant train wreck? Let's take a step back. Let's take a closer look before we jump to conclusions here. But to understand just the problem, let's see how Java ME UIs are constructed. There are 3 ways of doing this. One is canvas. We draw pixels. We own pixels. We decided already and discussed this that drawing pixels is not really a fast way to getting to UIs. LCD UI. It's one option. It's a very simple option. It has a set of widgets, and you just align them on the screen, and it gets there. That's it. And there is the lightweight UI toolkit, which is, lightweight here, it does not mean the weight. So in terms of the complexity, it's as lightweight as a hippo is, lightweight compared to a dinosaur, I guess. But it really is something that is a Java slang, so it's like self-contained. That's what it originally means. So let's get our targets here. So we want native-looking UI. We want it fairly simple, and we want it quick. So key, native look and feel. We are there for the right looks. And LCD UI is the story, or the winner in this regard for us. So it's a fairly high-level component, widget set that it provides us. It gives us the Nokia UI, the platform look and feel. It cannot be customized much, though, but that's not really a problem, because simplicity can be an advantage. There is a very, very limited set of widgets available for us, which means that if we are simulating or working around this, we don't have to work all that much, and we don't have to implement hundreds of different widgets. So of the 3 approaches that I outlined, which one would we use? Let's see. Custom components was the first one. So we retain Qt and then just have a widget set. What do you think? Would this work or not? There is some head shaking. There is a hand in the back.
No Qt.
No Qt. Paf. Okay, no Qt. Let's assume, just for discussion's sake, that there is Qt on the platform. Yes? Not enough resources. That is correct. What else? There is no native look and feel, and as said, the memory footprint is too large. And this is an ARM11 CPU and not really high clocked at that. So even if we had JavaScript working in there, it would not be fast. V8 already, we heard the discussion of how quick it is on different devices, but on these it would be dog slow. Okay, so this doesn't sound that good. Code generation. So could we generate maybe code, Java code, and then load that somehow dynamically? This requires a bit of knowledge. This is the part where I say that for these things you would have to know a bit about the platform. Here's the problem that I ran into. Java ME has no reflections, or class loaders. So you cannot have an application running that dynamically loads parts from the disk or memory. It's very, very tricky. Still, it's possible with application reloads. So if you're willing to restart the whole application again and again and again, then you can do this. So you go to full compile cycle, but that's a bit slow. Yep.
But could use this approach generating upfront, not at runtime.
Yes. So that's the thing, that if you are generating, copying it over, and then running it from scratch, the application, then it will work. However, in that case, you are actually very close to what the original workflow is. That you write the application, you press run, it gets compiled, it then gets copied over, it gets started there, it takes a while, and then it starts up. So then you are not winning all that much.
Okay, so it right now takes a very long time to do.
Yep. So it's
Okay.
yeah. And finally, clients like QML, as crummy as it is, turns out that there is a JSON parser. I have shown you a code snippet of how I used, for example, Tantalum to parse this and construct one. And we said with LCD UI we can get a native look and feel. That sounds promising. So let's take a look. And this is what we end up with. So on the left, there is, I couldn't include the whole thing. It was so long. So there was 3 classes, 6 methods, just for a hello world, and a simple form with an image and the text. And it's like 260 lines of code. So when I iterate over this, when my designer says like, okay, so how about we change the order of things, or we put some extra stuff in? It's like, okay, come back in half an hour, and then off we go. So and then we restart again. On the right side, instead of these hundreds of lines of code, this is it. That's the whole thing. And this means that whenever I'm doing this, if the designer, can first of all see right up front what's going on. So I don't need to be, a super duper programmer to understand what's roughly going on with this QML. It's fairly logical, the layout and everything itself. So it's also very easy to change. So we just reorder things, shuffle things, a line here, a line there. It's very easy. So the time it takes to try another iteration gets dramatically shorter. And what I'm doing here is actually something that is, since this is loaded on runtime, so I have the application running on the phone, I don't even restart. I just copy the QML file over. Every time the phone detects that the file has been renewed, I check this once a second, I just reload the application. So you can really literally have the phone in your hand, and you will see the UI change every time I press run or save on the QML file. And that's what makes it super, super quick, and to see what exactly I'm doing. So you can sort of like, as if it was somehow live coding on the device itself. Very, very nifty stuff. My sadness is I would show that right here, but that's actually on my Linux computer, and I don't have that one here. So I cannot show it as a live coding experiment. So you will have to go to GitHub and install it on your Linux computer and see for yourself and be amazed. All right. So I was afraid when I was starting with this that, hey, this is going to be a train wreck. No, it's not going to work. But then I was surprised because it's actually survivable. And you can try out things and make it, and make it live. That's a very, very important thing. Any questions? Yes.
There's no JavaScript in this.
There is no JavaScript in this. So that's a sort of the trade-off I accepted as that's what I have to live with. So this is just for constructing static UIs or mockups. So when we are trying out different layouts, how this works, because the platform is so limited in terms of widgets, that you just really have to try it out and see how it works. Otherwise, it's very hard, because designers will draw very nice interfaces which are not really possible in real life. And that's the most dangerous thing that you can end up with as a developer, that designers don't know what exactly is possible, and developers are unable to communicate that this just doesn't work that way, so you cannot do it. So that square peg round hole. And this makes it very possible, for example, for just validating approaches in literally minutes of how things work, because we have, otherwise normally it takes half an hour just to take an iteration of something to see whether it's sort of doable at all, and then you see whether it's what you wanted. Whereas here in half an hour you have a sort of half-complete mock-up UI that this is how I want it to look like. Navigation still doable, so I don't mind not having JavaScript here. So I'm not expecting anybody to write an application in this or with this. It's really about constructing UIs very quickly. And the same applies for cases when you are doing, for example, UI validation with people, so that you can also very quickly change, for example, on the fly and say that, okay, so if I'm doing a test with users, if I see halfway through the test that this is not working out, I can already do a change there and say, okay, so now let's do it a bit differently. A/B testing, whatever you want to call it. Okay, any more questions?
So you basically try to parse the QML with a JavaScript and removed all the stuff what you were facing when you loaded.
Right. So when it's as clean as this here, then I verify the first line just for enough to have the right version number in there. So I don't use any UI or any element that is not available for the version of the platform. And as you can see, I don't have any JavaScript or super dynamic things there. So for specific keywords, I can do my own implementation. So if I want to say I can on-clicked, whatever, then I can implement that. But be aware that I am implementing the QML in this whole story myself. So it has nothing to do with the, There's a question in the back. Yes, exactly. So the question was if I can extend this with an interpreter and then actually use it in live products, if I understood correctly. Right, so that's what I'm playing with right now, as to try to distribute this, for example, these QML files as part of the jar files and actually load it on the fly when I start from there. And this way, I would be dynamic UI updatable, so I don't need to reload the whole application, put it through the store. I can just download the QML and I have a brand new UI. I don't have to wait a week for QA, for example. The other thing is that so I've been there, so that's a very good thing. But the question is how maintainable it is, because appetite grows. So you will want to do more and more, and then your QML parser will grow bigger and bigger and bigger. So you have to be very clear from the start that this is the stuff I want this to do, and this is the stuff that I don't want it to do. Otherwise, it gets into this dancing competition where we are holding each other and trying to somehow make it to the deadline or something. But yes, that is one of the options, and that's something I'm playing with right now. Okay. All right. So we've seen one successful case study. So there was this device with OpenGL lacking completely, non-existent, no Qt, no nothing. It's a 64 meg device, ARM11. Qt would never run it successfully, especially not the full QtQuick stack. And yet I have a very simple QtCreator QML based workflow that is just speeding up things, and that's the key here. So I'm not saying that you should of course use Qt and QtQuick wherever possible, but we can use it also to speed up the workflow in cases where it's not available. Here's another case study from the sort of the other end of the universe. Embedded remote sensing. So here's a cool project, a Raspberry Pi board. There is tons of Qt enabled, Linux distributions available for it. It's an ARM11 device, but it does have OpenGL. So far, so good. But here's the thing: it's a remote sensing thing. So okay, so remote. We have some radio module. Here is this XB radio module. It has a very, very good line of sight range, up to 48 kilometers. Wow, that's super good. So this is, for example, going to be used in some ballooning experiments. So we can have telemetry, sent to us, or the UI, or we can actually log in maybe the whole thing on the balloon and do things actively while being attached to a balloon 30 kilometers up. And this is great. So, okay, so we have a UI. Let's say, for example, can we stream somehow this OpenGL? There was a story, for example, in QNX that we could maybe somehow do directly remoting the display and stuff, and all that sounds very good, but there is a catch. There is a 9,600 bits per second data rate. So yes, it's traveling 48 kilometers, but it's traveling sort of like with a very limited speed in terms of the bandwidth available. We need to work around this. So what happens when your world ends up with a Connect 9600? So those of you using modems might be familiar and or find this familiar, but anyway, well, if at that speed, graphical UIs are sort of out of the question. So what we are stuck with is command line interfaces or console UIs. Luckily, that has been around for ages, and some of the libraries there are fairly complete. There is the curses and its variants and PD curses, and there are even widget sets like Newt, CDK, or NDK++. But these are all pretty old. None of them are declarative. So you need to actually write all the stuff, just as with Java ME, add everything. So these are scripted at best, but they're really nothing. They have nothing that is remotely useful for quick UI prototyping. However, they are still useful for the reasons that I already outlined. It's low resource usage. Text takes very little bandwidth. We take very little memory as well. We don't need textures. We don't need images. All that's good. The distributable sizes are also very low. So that's all fun. So let's pick a toolkit. Let's go for CDK. This is what caught my eye when I was reading through CDK. It says at some point in the Linux documentation project, the conclusion for CDK is, all in all, CDK is a well-written package of widgets which, if used properly, can form a strong framework for developing complex, well, it says graphical, but it means textual user interfaces. Package of widgets. So what do we have here? We have 21 curses rendered text mode widgets. Looks familiar. It looks almost the same as a graphical user interface, and if you look at it, it's actually pretty decent. Yeah, of course, it takes you back a couple of years and to your childhood and all that, but still it's very useful. And as I said, it works at 48 kilometers away. So on the radio link, that's very good. So and you can see that these are actually fairly complex, the widget set. So we got matrix. It's not just label and such. It can actually draw graphs, histograms, and all that. So if this is, for example, transmitting or sending you some, for example, atmospheric data, then histograms and such are very useful. Anyhow, what approach are we going to use here? Let's see. First, custom components. What's your opinion on this? You say no. There is a no there. There's like a snicker somewhere, and
you can use it at design time.
Okay, at design time. In the back, yeah, we have conflicting opinions here. So the simple thing, QtQml we can run on the device.
Yeah, okay.
That much is true. We said okay. The thing is, we actually have widgets present. So there is the CDK. So there are some native widgets which do the heavy lifting, and it's a simple enough UI for memory JavaScript considerations. And here's an interesting one for maybe designers. The platform does not have a native look and feel. When we are in text mode, there is no expectation of how the UI should exactly look like. It's not as if there is a text mode design guideline. So we have it for Metro and iOS and other platforms, but for text mode it's a lot more flexible. So there is some rough expectations, but there is no strict rules there. So that's a very good thing. Okay. Code generation. What would be the pro and the con in this case? Here's my take on it. So first of all, there is a fairly large amount of widgets. There is 21, and some of those even have like certain subsets or options. So there is a large number of widgets. So if I want to interpret it myself and generate the code from that for all these widgets, that will be fairly complex. There is still no JavaScript. So yeah, I guess I could get around this and somehow install some V8 magic. I would end up halfway to Node.js by that point. but that's just an overkill for a UI prototype. Client-side QML. Pretty much the same problems. So there's a large number of configurable widgets. It will be maybe a bit easier than with code generation, but it actually takes still more effort than custom components. So I declared the winner personally, custom components, and that's how I did that. All right, and we of course have the JSON parser, but that's not going to help us much. And this is why I did it with with custom components. So on the left, we have how it's done now in code. This is actually the full code, so I didn't have to cut out parts and all that. And there on the right, we have the QML. Now here's the thing. So it's not that much shorter. It is shorter. It's, I would say, more terse, more understandable of what's going on. But from a UI prototyping perspective, the problem is with this part. So this is actually just printing a simple label which says hello world. So as you can say, it positions it in the middle. It has a certain width and height in characters. It has text, it has a border which has certain colors and all that. We have the exact same thing happening here. However, in the middle of the code, you say that there's like this message 0, 1, and 2, the lines. It has its own little language, how it constructs that box. And that's a pain. So whenever we have to do that and try to actually sort of script this somehow so that box comes out the way we want it, that's where you die. I tried it, it's very painful. So you end up with all sorts of artifacts on your screen, and it's messy. And that is exactly why the QML interface is so good. So when you are starting with that, you cannot mess it up. So you give a certain width, height, the attributes are very clear, so there is no way that the component can be rendered wrongly. Any questions? Again, I don't have the balloon here or my Raspberry Pi. Otherwise, I would be somehow connecting it, I guess, to this and then showing it to you. But again, same story. The Raspberry Pis are very cheap. Go to GitHub, download, install, and try it out. Yes?
Does it exist, and do you have all the widgets implemented?
I didn't implement all the widgets. So I did those that I needed most. So basically labels, boxes, histograms, and all that stuff. But it's up on GitHub. So I'm taking contributions, and feel free to check it out. I'm not sure how much interest there is in Qt as such or Qt project. If there is enough interest, we can of course upstream it so that it becomes at some point, if there is enough people interested in it, part of a like an add-on or something. But for this case, I'm just using it for prototyping. Still, it works very nicely for even for servers and all that stuff. So you get a more sane UI than just having a very, very crude command line interface.
So I don't get it right now. So you're only sending your custom components QML to the Raspberry?
Yes, I have my custom components. So that's a binary which I compiled previously. I have that on the device, yeah. And it's rendering. We're outputting text. Yeah. So when I put this, what comes out on the serial link is, like byte by byte, character by character. So it's a print essentially every time. So it's a very, very sort of simple or basic way of doing things, but that's why it's required for this low bandwidth connection. So I have this thing running completely on the Raspberry Pi.
What are you using to parse the QtQml or your JSON?
So in this case, I am effectively deploying the QML and running it on the device. So I have the sort of component set on Raspberry Pi, and I'm copying over this QML, and it gets executed on the Raspberry Pi.
Sure. Okay.
All right, but you can see that. So in any of these cases, the bottom line was that I didn't really care too much about the underlying platform. Whatever it was, I can kind of utilize it because QML is a very, very nice little language, and QtCreator and QtQuick in general give you a good background of leveraging all that. So, there is a number of potential targets. So you can use this for web, for example. If you're crazy enough, you can output, HTML. Why not? So yes, there are better tools. That's the only reason why I wouldn't do it myself. But normally you can also output HTML if you want to. You can go for Android as well. It also has a declarative output, so you could output that as well if you, for some reason didn't want to use, for example, the Android build of Qt, which is probably more sane. The same story for Windows 8. You can generate XAML, whatever you want. So, you can insert whatever hardcore platform you want So even if the tooling sometimes seems awkward and the approach maybe not, the way it's supposed to be done, but still for prototyping purposes, it's very good. And in my case, so the takeaway, I was saying here, fail fast, write quick code, write, iterate your UIs fast and all that. But it's actually, at the end, I decided that I want to do and say something a lot simpler. So it's not about where Qt can take you. It's about where you can take Qt with you. So we are using Qt and QML on platforms which didn't really have any sort of interest in Qt or have very little relation with Qt as such. And yet, because of the simplicity and the beauty of QML as, for example, as a technology, we can still use that for very, very, very good and efficient prototyping. So don't give up on platforms just because somebody says like, well, we don't have Qt there, or the Qt support there is not good enough. So if there is a good enough business interest, if you want to iterate quickly, you can still use Qt and QML as such. So it's a very, very good thing, and you can come up with component sets, whatever. And if you do it, then please do it in open source so that we can all share and improve, because there is a lot to be learned here. I think that is a fairly unexplored area still. All right. Any questions? Well, if there are no questions, then thank you all. Thank you very much. And that was my session about fast QML UI prototyping for platforms without Qt and QtQuick support. Thank you.